Hi, this is Arshad Devani, a tech speaker and an entrepreneur. As part of this workshop, we are going to start generating images. And before we start generating the images, we are going to understand how images are generated in AI. We are going to learn about GANs, and we are also going to see the use cases of how these images are being generated as of today. We are going to start utilizing ComfyUI, which is an amazing tool to use different types of models. And we are going to generate images on our local system using this particular laptop which we have, and it is going to be very quick, very awesome. We are going to see and we are going to create a lot of images as part of this particular workshop. As part of this workshop, we are going to use MSI Raider 18HX AI, which is powered with latest Intel Core Ultra 9 processor series 2, coupled with the NVIDIA Blackwell GeForce RTX 5090 laptop GPU with a total TDP of 260 watts. This powerhouse ensures uncompromised speed for gaming, AI workloads, and content creation. Featuring a stunning 18-inch 4K mini LED display with 120Hz refresh rate, it is crafted for creators and it elevates the experience for all the gamers. The addition of Super RAID 5 SSD technology ensures blazing fast storage performance, enabling quicker load times and seamless multitasking. Now let's bring up the ante. Let's start looking at how images are getting generated as part of AI, how things can be done differently, and let's see how machines do really create all of these images. Now there are a lot of other things, but to make sure that all our audience can understand this well, we're going to have less technical knowledge, less technical words and jargons, and we are going to understand the whole of this generation process in a very simple way. We call this as Generative Adversarial Networks, or GANs for short. Now, this is generally a jargon which is being utilized. So GANs are what are commonly called. So you'll hear any of the engineers or technical people talking about GANs, understand they are talking about Generative Adversarial Networks. And let's look at this in a very different perspective. Imagine that there are two teams, okay? So there is generator and there's a discriminator. So the generator and discriminator always keeps on fighting. Everyone wants to be a devil's advocate. They want to fight against each other. So now understand it in this way. The generator is the one who's going to go ahead and generate something out of something which is available. And then the discriminator is going to go ahead and say whether this is real or not. And they are the judges in terms of saying whether this is a final generated image or not. Now let's look at this in a very different perspective. Generator generates, discriminator judges. Let's look at how these things work out. It's like a fight between an artist and a critic, right? So if you are an artist, you will have a very different perspective. And as a critic, I would look at a particular same image in a very different way. I'll try to find out very different things as part of very different images. And that is what exactly happens as part of various stages of image generation. Now let's understand it from a generator's perspective. What all happens as part of this? So first, imagine that there is some random noise vector. Now we'll bring this down a bit for everyone to understand. So imagine that there is 0101. You might have seen so many images out in the market where there are just simple dots. I hope everyone knows how an image gets generated. Imagine that there is 1920 by 1080, commonly known as Full HD. So you would create those images and each of those pixels are basically considered as one box or one dot. And to create a very good image, you would put up dots close by to make sure that you will have a beautiful image. Now imagine that there is an image which needs to be created. There will be several dots on different places. And when these are seen from a higher level, it looks like a proper image, something which you wanted to generate. So the generator starts off with this particular part, So you would start off with some random noise vector wherein, the dots and everything are available in a very big space. Now, when this happens, imagine that there are layers and layers built on top of this, one after the other. And let's say, for the sake of explanation, different colors as well. And when all of these layers are combined in together, they create an image. And furthermore, if you want to make it more realistic, you would have to blend in those images as well, or blend in those dots as well. And when they are placed on top of each other, it would just combine in together to give you a beautiful color. That is exactly the way how images generally get generated. Now let's look at it from the discriminator perspective. When the discriminator looks at a particular image, it tries to see that there are dots in between. When there are dots in between and there is a small issue in those dots, that's the point where the discriminator falls into the picture and says that this could probably be fake. Now, when this happens, at that point of time, it is basically analyzed from 0 to 1. In other words, 0% to 100%. So when it is 0.90, it means it is 90% accurate or 90% real. So the discriminator keeps on looking all of those images, all the dots which are generated, and it tries to match, saying that this is the right one or not. In this way, a generator and a discriminator works in together to finally create an image. Now you might think these are all something which I am not able to understand it well. That's fine. Let's try to understand it furthermore now. So let's look at the GAN feedback loop as to how all of these things happen and how does the generator try to fool the discriminator to make it look better. And it is a loop. So it just doesn't happen in one shot. It takes multiple takes, multiple steps to generate something. And this is what is important while creation of any of the images. Let's look at the GAN feedback loop. Let's look at the training process as to how things work out. So first comes into the picture is the adversarial game. So when we just discussed about this, so generator and the discriminator keep on playing against each other. They try to understand what is getting generated and whether it is real or not. It tries to keep on getting in, combining in together, and it goes in an iterative process, one after the other, one after the other. The final goal to generate the image is basically very simple. You need to differentiate between what is real versus what is fake. So when there is a real image, at that point of time, you say that, okay, this is a generated image. So you would go for iterations one after the other. And then at one particular point in time, you would say, based on particular set of steps and the config which has been taken, there is this point where the image is finalized. And that is basically the generator goal. Now this is as part of the training process. So you would do a lot of times this whole iteration process when you're creating your own models, of course. And then that is the point wherein you would say that this is a final image which has been generated. Now it is important that there has to be a good accuracy percentage, because no one likes, let's say for example, I would say create an image of a pup and a dog playing in together. Now when that happens, nobody wants to see some other forms of images which is apart from, let's say, dogs. Now the discriminator needs to be good to understand whether this is really relevant or not, and if that fails, at that point of time you get an image which is very, very difficult to justify, saying that this was the prompt which you had brought in and this is the output of that. So it is really important to have the right set of balance between the generator and the descriptor. Now let's look at the training convergence process. So what happens when there is no balance between these two? At that point of time, there has to be a point where both of them collide, right? So in case if they don't collide, which means there'll be issues in terms of the image generation. What types of issues? Let's look at some of those things. A lot of times you might have seen that the images get generated very dark. So look at this image which is towards the right. It is very dark. It is very difficult for native eyes to actually see this particular thing. Since I'm sharing the screen, you might be able to see this very clearly, but when you see it from a perspective of an actual generated image, everyone might not be able to get it. Wouldn't it look beautiful in case if it was looking something similar to this one, the left side one, where the lighting and everything is very good? Of course, everyone would love to see the one which is towards the left and not towards the right. So this could be a lot of, this could be an after effect of the convergence issues. So in case if the training has not been done properly of the right set of models and everything, it could cause color fading related issues. We will look at this in practical as well. And there could be network limitations as well, because when the training and everything happens, there could be a lot of data which is input and output. When you are putting up the prompt and everything, during the network gaps and everything, whenever there are issues in between, it could be one of the outcomes of that as well. And the normalization effect as well. We will definitely discuss about normalization effects in the future workshops, but then this is exactly one of the outcomes when you would see when there's no convergence happening. Let's look let's look at a different perspective as well. What are the different types of generator systems which we have now? There are different types of kernels. Again, this would go a bit technical, but then we'll try to keep it at a much more lower layer. So you would have different types of textures, you would have different types of colors, you would have different types of shapes. Each of these are basically understood by the model itself. So you would say that each and every different color, when they merge with the other color, how would it look? Right? So you can see a blend of just a particular set of colors, wherein of course, if you know the shades right, there are different shades of blue. When they come in together at that point of time, it looks very different, right? And it creates a mesmerizing effect. So this is one of those images where you can see the mesmerizing effect, wherein literally few set of colors combined in with white and black can create a lot of different set of gradients, and when these gradients come in together, that's the point wherein you would see photorealism. You would see a lot of different types of images which will look better. So this is about the generator brushes. Now let's look at exactly what are convolutional kernels, visualizations as to how these brush strokes come in together to really create all of these images, and how does it get painted. When we talked about the layers coming in together, when there are dots which needs to be combined in together to create a beautiful gradient and everything, how does that really work out? So basically there is a secret sauce behind it. There's a secret code behind all of these images. So the vector embedding is basically a process wherein each and every dots and everything, the way how things work out, they are placed in form of vectors. Now vectors, in other words, if you would remember, and an easier way to remember, I'm sure as part of your math classes and everything, you might remember this particular formula, which is y is equals to mx plus c. M is a constant and y and x are variables, right? So when we are saying y and x, these are basically the variables. These are the parameters which you're going to go ahead and provide. So similarly, when you're going to put it up as part of vector embeddings, imagine a case where there is a very long equation which is having multiple parameters. When all of these parameters come in together and then they give out a final output, that's what you would do it as part of vector encoding or vector embeddings. When you would get in all of these vectors together, at that point of time, you would be able to find in a data. So anytime a data is coming in, they'll be broken down into multiple vectors, and those vectors are basically the ones which are generally stored. It becomes easier to search out through these vectors via different ways, like cosine similarities, so many different ways to get all of these things. And then when all of these vectors are combined in together, there has to be a transition between all of those. So when there is a transition between all of these things coming in together, that's the point which actually goes ahead and creates a beautiful image. And let's look at the latent space interpolation. By the way, the images whichever you see are all AI generated, all generated from my local system. They have not been utilized from any of the LLMs available online. So let's look at some of the latent spaces as to how it really creates a whole smooth transition between the images. And generally you would see that when there is an image as such, so you can see that the image related things which are here, each of these images, if you see the way how it works out is the vertical spacing. So in a vertical line, so when you see an image, it is having a very small minute difference between each of these images, and when it passes via the different images, so the way how it goes is it goes straight towards the down, you see towards here, and then it goes back again on the top, and this is how the image gets generated. So now when there is a small difference, you will not be able to make it very easily, but when you see it side by side, you can see the kind of differences which are there available in between all of these things. So this is the way how when there is a video or something which needs to be created, there is a transition which happens. So there is one after the other images which are generated with very minute set of changes, and then when they combine in together one frame after the other, that is the point wherein you start looking at a video. So this is the way how the interpolation happens between the different set of images, creating a transition effect. Let's look at some of the applications of where this generated images could be utilized. I'm sure you might be seeing so many different tutorials on the internet wherein you see that you can utilize AI to not only just create normal images or the Ghibli art, which I'm sure you might have used, but then you can utilize AI for doing a number of other things as well. So let's say digital avatars, which is of course one of those examples, is the most famous Ghibli art. And then you can utilize AI to not only upscale images, but you can even make them much more clear, much more crisp, much more better. And then you can utilize this for creating data augmentation charts. Like let's say for example you had a lot of data, you wanted to create graphical charts out of it, you can utilize AI to do that as well. And then imagine a case that you had an image which was long ago, right? It was probably in the earlier times wherein we used to be in kind of monochrome spacing, or probably just the black and white color. At that point of time you can utilize this particular set of images, you can recolor them using AI. It's as simple as that. Let's look at some of the examples. So you can see that there is this image which is a very old image, and you can see an image using AI when it is getting converted into a good image. So you can see the skin tones, you can see how realistic the skins and everything look, and the color effects and everything. So have you ever thought how each of these pixels and everything would come in together to really create this image? If I actually go ahead and try to zoom more as part of this, let me see if I can do that very quickly. Okay, I'm not sure, but let me again try to do this. But if you try to see this very clearly, you'll be able to see that the skin texture and everything, those has those pores and everything, the hair, fine line hair which is colored in blue, everything has very fine minute details. This has not only been transformed from black and white to color, but this has also been upscaled, beautified way more to look better. So what would you prefer to look? The left one or the right one? Let's look at what's next. We can see some of the challenges and everything in the GAN training process. So there could be cases where it produces very limited similar images. So in case if there were continuous sequence of images to be generated at that point of time, the images are not set in right, which might not give a good transition effect. The steps are not done well. At that point of time, the whole mode collapses. And if there is no convergence point, at that point of time there's training instability, which basically means that because there was no convergence point wherein the creator or the artist and the judge were not able to come to a conclusion, or the generator or the discriminator were not able to come to a conclusion, at that point of time the image just doesn't get generated right, which we already talked about before. And then when there is an imbalance in terms of the percentage between the generator and the discriminator, that is the point wherein you start having balance issues. So these are some of the greater known challenges in GAN. And these are some of the architectural innovations wherein style GAN, big GAN architectures, these are more technical related front in terms of how you can improvise all of these things. And then let's look at some of the evolutions about early versus modern. You can see towards the left, these were somewhere around like 2022 2023, where you would see the images which are generated. As you can see, the pixels and everything are way more clear. They look, you can see the pixels and everything which are visible. And then towards the right, you can see the way how modern GANs look, right? The skin tone, the textures and everything, they look way more clear. In summary, let's look at what we have discussed so far. So it is basically the generator starts off with a random noise, wherein you start off with some of the dots and everything, then it goes via the whole transformation process where all of these layers are created one after the other. And then there is the discriminator feedback which comes into the picture, which says whether this is right, this is wrong. The whole transition and the convergence point comes in together to finally give a photorealistic results. So that's what we discuss. Now there's a lot of discussion happening around the theoretical part. Let's look at something which is more practical. Have you ever thought to create some image of your own? Let's see how you can do this locally as part of your system. Like I said, I can go ahead and I can generate this as part of my system. A lot of these images which have been generated, actually almost all of them have been generated on my local system. So let's try to see how we can generate this as part of our local system. So what we're going to start off is with something called as ComfyUI. I'm not sure if you have heard about this, but what you can do is you can directly do a Google search of ComfyUI. When you do this, you will directly be going on to comfy.org. This is the place where you go in and you just have to click on download. Now you can download it for Windows or you can download it for Mac. This is basically going to ensure that you're going to have everything. My personal preference would be to go ahead and install it from GitHub, which is going to basically give you this whole source code coming in together. And then as part of this, you'll be able to see that there is an installation flow. to all of these things. There are of course different models which we are going to look at it very shortly. Once you download it, you will be having, so I would generally take a portable package. This is what I generally prefer, Windows portable package, which will take you to this particular part of the releases page, and as part of the releases page you will be able to download this direct source code, or you can directly download this one, portable NVIDIA, which you can put it as part of your system. I already have it downloaded. I have kept it extracted as well. So let's look at that. So once you get into this, you will find that there is ComfyUI, Python embedded, update, a couple of more other bat files which you can go ahead and which you can utilize. We are going to use the run NVIDIA GPU, which is going to go ahead and generate. Let me close off what I was already having it existing so that we can check these things out. So once it has been downloaded, all you got to do is click on run NVIDIA GPU. Now again, like I said in the last videos as well, it is important that you have a very good GPU to generate all of these images. We are going to see that how long it is going to take to generate an image. It is going to take a couple of minutes for us to generate some of the images, but let's see how it works out. So we are going to use this run NVIDIA GPU and just double click on that. Of course, it might ask for permissions. It's safe. You can go ahead and click on run. And when you do that, it will take a couple of seconds. So what it does behind the scenes is it is going to get all the downloads, get all the models and everything. It is going to check out all the different types of models which are available. In case if there are any dependencies as such which needs to be installed, it will go ahead and it will do that as well. Do remember that you require Python 3.11, if I'm not mistaken. That's the minimum thing which you would require. Once all of those things are there, and then you will be able to generate some of the images. Oops, I have something which is already up and running. We'll just go on to the new so that you don't end up in seeing all of those things. Sorry for that. Let's look at the docs of ComfyUI to make sure that we can generate. You can see the whole documentation of ComfyUI is really very good. You'll be able to see, and the beauty of ComfyUI is that you can go ahead and you can generate your own set of images and everything, and you get the ability to select different types of models. So you can decide which are models you want, and then based on that you can decide what all things you want to do. You can go ahead and you can generate not only just images, but you can generate 3D, video, audio, and so on and so forth. Everything is a node based editor. We'll see that very quickly. It's like simple nodes to be added, and then once you have added all this nodes, at that point of time you can go ahead and you can generate it. We are going to go ahead and we are going to generate image, and for this particular video what we are going to do is we are going to use Gwen image. Now you can see that it gives you a complete detail set around all of these things. You will be able to find the Hugging Face. I'm not sure if you know about Hugging Face. Hugging Face is a fantastic repository of all the different types of models which are available. I have opened it up right here and I've logged in as well as part of Hugging Face. So you can literally find all the different set of models which are publicly available. So for example, one of the most frequently utilized ones is Stable Diffusion. So if you search for Stable Diffusion, so if you search for Stable Diffusion, you can see that there's Stable Diffusion XL, which is for generating extra large images, the bigger models. And then you have Stable Diffusion 3.5 large. You also have Stable Diffusion 1.5, which is a little bit older but still in use at a lot of places. And then you can go ahead and utilize literally anyone. So let's say for example, if I were to utilize Stable Diffusion 3.5, I just click on it, it will show me the examples and everything. It will talk about the models as well as to how the models and everything work out. I know this looks very complex, but trust me, it's the same thing which we just discussed a couple of minutes ago. So it is going to help you to understand all of those things. You can check out the licenses and everything. So you cannot use it for you can use it for non-commercial purposes and everything, and then there's a limit in terms of how much you utilize this as well. So you can always use the community license one for non-commercial users, but then in case if there is something which you want to go beyond, and there's a capping in terms of the revenue. So in case if you go beyond that, you have to see you need to reach out to the Stable Diffusion folks. All of these things are available as part of the community license agreement, as well as the licenses which are available. So feel free to reach out to Stability team. And the model sources, so they do expose all of these model sources wherein you can check out all the different types of details. It tells you about how the mixed resolution images works and what are the training stages of those, the encoders and decoders which are available. Encoders and decoders are a way for you to say how generator and the descriptors will work. Sorry, discriminators will work. And there is also a different concept wherein you can utilize the diffusers. So what are diffusers? Diffusers are a way for you to say that there's one single file which you can run across different places, and when you do all of these things coming in together, you can probably utilize it as part of your mobile application development, wherein you just give the diffuser file, and then based on that you can run it directly as part of your system. So let's look at the way, as in there of course you can go through the whole documentation here as part of ComfyUI, and then you have the files and versions, which is basically the files, the actual models. You can see that SD 3.5 medium, safe tensors. Safe tensors is the file which you would have for the checkpoints. You can see that this file is of 5.11 GB. I have good amount of models which are there on my system, which are like at least like 40 GB as well. So let's look at some of these things, and since the ComfyUI is up, we can check out as part of it. Let's try to go ahead on Quen. You can find out all the different types of information. You can see that there is link to the Hugging Face as well as the GitHub, so you can go through everything around it. You can it also gives you a nice good update of saying how you can download the ComfyUI, and there are some models which run only on the latest versions of ComfyUI, so you can just check it out, and all of those things as well. Also you can see that there's a VRAM or GPU RAM which is recommended as part of this. So you can see RTX 4090D, 24 gigs. Currently I'm utilizing NVIDIA 1590 with 24 gigs, which is the latest one available, and this is on my Raider 18 of MSI, which is an amazing laptop to work around with. Let's try to recreate exactly this particular image. Now it is very easy, right? When you see all of these kind of images, it becomes very easy to go ahead and run this images and try to create all of these images. All I got to do is just drag this particular image into my workflow, and you can see the whole workflow has been created. Let's try to understand what exactly is there as part of this. So what it first does is it is going to load the model. It is going to say which particular, I already have this model downloaded. Just in case if the model has not been downloaded, it is going to prompt you to say that you know, there is a model which needs to be downloaded. Just for the example, let's go ahead and try the High Dream, or let me go ahead with Cosmos Predict, which I have not tried it so far. It can generate images as such, so you can check it out. So what I'm going to do is I'm just going to go ahead and drag it into ComfyUI. When I do this, it automatically tells me that these are the missing models. So you can download this. You can see that there is a text encoder model which is close to around 4.56 GB. Then there is VAE, which is basically going to be like close to around 242 MB, not much. And then comes the diffusion model, which is again a bigger one. So you have to download all of these things and then place it in the right set of folders. What are these folders? So you need to go ahead and paste it after you have downloaded. You need to move them to the right set of folders. So as it said that it needs to go into text encoders. So what you will have to do is you will have to go into ComfyUI under ComfyUI, and under models you'll have to go under text encoders and you'll have to place it there. Once you place it here, that's the point where you'll be able to go ahead and you'll be able to start utilizing all of those things, and it auto refreshes, so you don't have to bother about actually again reloading the whole stuff. In most of the cases it auto reloads, so you'll be able to see that the models are available, and then you'll be able to proceed forward with it. So you just have to keep on getting all of these different models. So let's try and go ahead, and we'll go back to the Quen image, and this is what we are going to try it out. So the first part is the load models part, the second one is the load clips part. So all of these have basically been taken, and you can see that there is there's a prompt which is written. I'm sure you might remember the kind of prompts which we had written. Let me quickly copy this particular prompt, open it up as part of Visual Studio Code, and open this up here. Sorry, not this one. Let me copy it. So you can see that this particular prompt says a vibrant, warm, neon lit street scene in Hong Kong at the afternoon with a mix of colorful Chinese and English signs glowing brightly. The atmosphere is lively, cinematic, and rain washed with reflections on the pavement. The colors are vivid, full of pink, blue, red, and green hues. Crowded buildings with overlapping neon signs, 1980s Hong Kong style, signs included. Let's try to modify this a bit and see how this looks. I don't want to utilize all of these different characters which I'm not fully aware of. And let's try to see how we can get rid of this one, and let's get rid of the prompt to make it a bit more better. So we are going to say crowded buildings with overlapping neon signs, not the 1980s, but let's see how this looks in 2050s. And not Hong Kong, 2050s, neon signs, simulate building designs of 2050s. Let's try to take hold of this. We're going to paste it up here, get rid of the just for the sake, there was an extra quotation, so we're going to add this up, and then let's see in case if there's something else. So you can, when you're utilizing ComfyUI and when you're generating all of these things, you can go ahead and you can give in the negative prompt separately. So when these are going to combine in together, at that point of time, it becomes very easier to go ahead and use it. The recommended model says that you would utilize it with 40 steps, which is basically 40 cycles of the training related thing with CFG 2.5. So we are not going to go ahead with so many things. We are just going to have steps as 20 for now, and then CFGs as 2.5. So let's see how this will work out. I think we have all the things running in, and all you got to do after everything is set in. Okay, we didn't talk about VAs. VAs are basically way for us to say that these are the encoders and everything which are basically being utilized, and you can specify the image size. I'll probably just make this as 1080 for now, and the height also as 1080. Okay, sorry, I made it as 1080, and I'm not sure what is happening with this one, 1088. I'm not sure what is happening in here with 1088, but that's fine. I think we can go ahead with this one. All we got to now do is just click on run, and when that happens, you can see the particular step which is being utilized will be highlighted in a different color. So you can see that it is in green color, and now it is going ahead with the load diffusion model. So it is actually loading the whole model right now, and this is quite a huge model. So the model will take in, the model will get loaded, and then it is now going into the case sampler, which basically means that it has now started generating, and you'll be able to see some progress coming in very soon quickly here on the top. But you can also hover on the tab bar of your browser, which will say that how much percentage has been completed, and now you can see that there is a loader item which is happening in as well. So when the loader completes, that basically means that the image is getting generated at that point of time. While this is happening, let's look at the sizing of this particular models and everything. So I will go back to ComfyUI with Gwen image. So you'll be able to see that the size of these files are quite huge. This was the example image which we just utilized. This particular one which I'm utilizing is of 40.9. Sorry, I'm utilizing the FP8 one, which is close to around 20.4 GB. The model was quite huge. It took me a couple of close to around like 28 to 30 minutes to download this particular thing because I was having a very bad network. But then you can go ahead and you can utilize the higher ones also. So definitely the quality will improvise when you are utilizing the higher ones, but that also means that you will need to have a higher GPU to go ahead and generate all of these things. So make sure that you are reading this whole particular documentation in full when you want to do it for your bigger set of projects and everything. Of course, then there's LoRa, which has been added up, and the text encoder. In terms of the references, you'll also be able to see that, so you can download it directly from this particular set of links as well. And then these are the places where you need to place it up, like we said. So text encoders, you have to put it in text encoders folder, the VAs and VA folder, the LoRa's in the LoRa's folder, and the diffusion models in the diffusion folder. Once all of those things have been done, then you can go ahead and you can utilize. This is the exact same workflow step by step which we had utilized, along with the steps as well. So in case if you are more text heavy person wherein you want to do it by yourself, you can definitely go ahead and do that. I think it has been generated. You can see that this image was generated. It is slightly different from what we had seen. Okay, so you can generate it from here as well. So it took close to around 106 seconds, which is pretty neat in terms of an image generation related things. And look at the way how beautiful it is. It is something very similar to what we just saw here. Of course, because the image was much more descriptive before, wherein it said that you need to have a lot of different boards, signboards and everything with the names and everything specified, so that is why it is having much more granular level thing. But then we didn't specify some of those things, so it went ahead and it created this kind of an image. Let's try to generate one more image. What we are going to try and do is neon lit screen in Hong Kong. So as you can see, we had specified Hong Kong, so that is why it ended up in creating a scene which is equivalent to that of Hong Kong. So let's try to go ahead and try to create one more prompt around this. So we are going to create it something like, so as you might already be knowing from the last videos, I love being as part of Dubai. So neon lit scene in Dubai at not an afternoon but in evening, with a mix of colorful Chinese and English signs. Not really, so we are not going to say colorful English signs glowing brightly. The atmosphere is lively, cinematic and rain-washed, not rain-washed, lively and cinematic, with the reflections on pavement. The colors are vivid, full of pink, blue, red and green hues. Crowded buildings with overlapping. Add Burj Khalifa building exactly in between with the view of the whole city of Dubai. And let's see with this particular prompt as to how it looks. Okay, let's try to run this one more time and let's try to look at the difference. So right now it is going into the case sampler mode. Now you might have seen that the first time when we tried generating, it took a couple of seconds to load the model, but now it is very quickly onto the case sampler because the model is already loaded right now. It is there on your virtual RAM or the virtual memory. So it will go ahead and it will load up way more faster. We are already at the case sampler level, and I am pretty much sure it will take a couple of less seconds than earlier before to generate the image. Let's see how this looks out. We'll wait for a couple of seconds. While this is happening in, make sure that you generate your own set of images. You can definitely share in your images as part of the video comments. Try to generate different types of images. Be creative and let's see what we can. We'll try to make sure that somebody gets some cookie points around this particular part of your images which are going to get generated. We are always on the lookout for beautiful images. We are soon starting off another page where we are going to push in all of those images, whoever is going to share it with us as part of those set of things. By the way, if you didn't know, there is a special tool for MSI people. So there is a software, or there is a utility called as AI Artist. If you have not heard about it, let me quickly show you how this looks. So AI Artist, if you look at all of these things, and I'll type in MSI, which will basically take you to this page directly. So when you go onto this particular page, you'll be able to see that there is a dedicated application which gets created for MSI systems, which is way more optimized, and you can generate multiple images at one go to go ahead and generate your own content. So you can go ahead and utilize this. This is particularly on MSI laptops, which it is available for now. So it goes ahead and you can generate images directly using this. So this completely uses your local system. It uses stable diffusions behind the scenes. It's an optimized version of stable diffusion, which helps you to generate all of these images. And guess what? This is completely free for MSI people. So make sure if you have an MSI laptop, go ahead and download this particular software. You don't really have to go via the ComfyUI related part. It can generate this on your system without any other software or any other tooling which is required. And if you don't have an MSI, make sure you have an MSI notebook or desktop to go ahead and use such beautiful hardware. So you can go ahead and have the GTX or RTX 5070, 5090 series. I'm using the 5090 series, and you can see the image generations have been beautiful. All right, so this took 93.15 seconds, which is close to around like 10 seconds quicker. You can see the way how this looks out. The Burj Khalifa is right in between, way more modernistic, and everything included as part of it. Isn't this beautiful? Let us know what you are generating, and we'll be more than happy to see how things work out as part of your things. Stay tuned. We are going to still create few more images, and we'll see you as part of the next workshop where we are going to use another set of models to generate images. See you again soon. Bye-bye.